All right, so we're in section 9.2, and we're talking about arithmetic sequences and series and partial sums. So we've talked already about what a sequence is, and when we add the terms of the sequence together, we get a series, and we've practiced a little bit with coming up with the pattern and figuring out how our sequences and series work. An arithmetic sequence is a special kind because it has a nice pattern that makes them easy to work with. So we call an arithmetic sequence an arithmetic arithmetic sequence means that each term is different by a constant number. So each pair of terms So each pair is different by a constant. And the way we write that is we can write a sub n equals a sub n minus 1 plus d, some constant. And we call d is the common difference. So an example of this would be something like 2, 4, 6, 8, 10, ... The difference between each of these two terms is 2. So that would be an arithmetic sequence because the difference between each pair of terms is 2. It's a constant. So we just get we get the next term by adding our common difference here, 2, to the previous term. So this would be an arithmetic sequence with a difference equal to 2. So if we're given some arithmetic sequence, to find the common difference, all we have to do is subtract one term from the term before it. So another example, if we wanted to find the common difference, another arithmetic sequence, if we had 5, 8, 11, 14, and we know this is an arithmetic sequence, we can find the difference by subtracting any of the two terms. So here our difference is just 3. Each term differs by 3. If we had something like 15, 11, 7, 3, and it keeps going, here our difference is going to be what? -4. So each term goes down by 4. So to find our common difference, we just subtract two terms, two consecutive terms. And that's what we mean by an arithmetic sequence. Now when we've talked about, so far when we've talked about sequences, we're interested, we want to come up with a formula where we can plug in n equals 1, 2, 3, 4, and figure out what the term is. Doing this doesn't tell us what, we couldn't say, for this one to find the 25th term, we'd have to keep adding 3 until we got to the 25th term. And if we wanted to find a really large term, the 2,732nd term, that would be really hard. So we want to come up with a way that we can relate the term to n, to 1, 2, 3, to its number. So let's work on that. So we want to figure out a formula for the nth term. So we're going to write our first term. We're going to say a sub 1 is our first term. So that's just, and that's our first, just our first term. And we know that our terms differ by a constant. We know our terms differ by a constant, so we can say that a2, our second term, is just a1 plus d, where d is a common difference. So a2 is just a1 plus d. a3 is a2 plus d. But a2 is a1 plus d. So I'm going to, if I plug this whole thing in right here, I get that a3 is a1 plus d plus d. So that's a1 plus 2d. I'm just plugging this in for a2 here. And a sub 4, my 4 term, is a sub 3 plus d. We're just adding the common difference to a sub 3. But a sub 3 is a1 plus 2d. So I'm going to take this and plug it in here. So I get a1 plus 2d plus d, or a1 plus 3d. So does anyone see the pattern here? A sub n equals a1. Here n is 4, and this number is 3. Here n is 2. This number is 1. So my a sub n is going to be a sub 1 plus n minus 1 times d. So here's my formula for my nth term. If I know the first term, I can find any term using this formula. Just plug in n here for whatever n is. So if we had some series and we wanted the 2,375th term, we plug in 2,375 here, add it, multiply it by d, multiply or add it to the first term, and we'd have our 2,475th term. And we can call this our nth term formula. Any questions on our formula? And that's one thing that's really nice about arithmetic sequences, is that our formulas are pretty easy and straightforward to work with. So let's look at a couple of examples using our nth term formula. So let's say we have an arithmetic sequence. A sub 1 equals a sub 1 equals 9, and the common difference d equals 5, and we want the nth term. So we just want to write our formula for our nth term. So our nth term, we just use our formula that we just came up with. A sub n equals a sub 1 plus n minus 1 times 5. And I'm going to simplify this a little bit. I'm going to distribute here. So a sub n equals 9 plus 5 times n is 5n minus 5 when I distribute here. 9 minus 5 is 4. So my a sub n is 5n plus 4. So that would be the formula for the nth term of this particular sequence, 5n plus 4. So we can plug in any n and figure out our nth term. Any questions on that? Yes, Cedric. I distributed the 5 here for my n minus 1 times 5. So I just distributed the 5. All right, let's look at a little more complicated example. Takes a little more work. We have an arithmetic sequence. Let's see, our fifth term is 19. And our ninth term is 27. And we want to find the nth term. Now this one's a little more complicated because I don't have my first term. I have my fifth term and I have my ninth term. I don't have my first term. So I can't just plug into my formula for a sub n. I have to do a little more work. So I'm going to use my nth term formula for both of these terms. So I know that a sub 5, using my nth term formula, a sub 5 is a1 plus n minus 1, 5 minus 1, times d. And I'm just going to rewrite that as I'm going to distribute the d here so we know what we're doing. So a sub 5 equals a1 plus 5d minus d, or a sub 5 equals a1 plus 4d. Yes?
You go from first from 5 minus 1 and then add this d into there.
Sure, you could do it either way. We'll do it that way next time. And I'm going to do the same thing for the ninth term. A sub 9 equals a sub 1 plus 9 minus 1 times d, or a sub 1 plus 8d. And I know that the fifth term is 19 and the ninth term is 27, so I'm going to go over here and say from this set of equations I get 27 equals a1 plus 4d. I'm sorry, 19, thank you. 19 equals a1 plus 4d. And from this equation, I get 27 equals a1 plus 8d. Anybody see what we need to do here? We have two variables. We have a1 and d, and we have two equations.
Solve for D.
So
First
we
one, plug it in.
solve for d in the first one, plug it into the second one. So we need to solve simultaneous equations. Here we have two variables, two equations. So there are several ways that we can do this. Elena suggested we solve one for D and then substitute that into the second equation. I'm going to make it a little easier. Because both of these have A1, I'm just going to subtract one from the other. So I'm going to write 27 equals A1 plus 8D, and I have 19 equals A1 plus 4D. I'm going to subtract the bottom one from the top one. 27 minus 19 is, what is it? 8. A1 minus A1 is 0, and 8D minus 4D is 4D. So 8 equals 4D. This tells me that D equals 2. Then I can substitute this D into either one of these equations to solve for A1. So let's put it into this one. Into the top one, 19 plus A1, 19 equals A1 plus 4D. So 19 equals A1 plus 4 times 2. I can solve this for A1, and I get A1 equals 11. So now I can write my nth term, finally. Nth term equals A1, 11 plus n minus 1 times D. And I'm just going to simplify this by distributing. That equals 11. And D is 2. Needed to write 2 here. 2n minus 2. And finally, a sub n equals 9 plus 2n. So that one took a little more work. But we ended up with 2 equations with 2 variables and had to solve those. Questions on that example? All right. So we know about sequences. We know how to find our nth term now. Now we want to figure out how to find the sum of our sequence. We want to add the terms together. That's what we did yesterday, is talked about how we find sums. We're adding the terms of our sequences together. So that's what we want to do next with arithmetic sequences. So we want the sum So we're just going to add together terms. And arithmetic sequences are nice because we can come up with a formula for the sum. So the sum of n terms the sum of n terms of an arithmetic sequence, and we write that as S sub n is n times a1 plus a sub n divided by 2. And if you're interested at all, I can show you where this formula comes from. The formula is not very hard to come up with. But to find our sum for n terms, we just add the first term and the last term. A sub n is our last term. Add the first term and the last term, multiply that by the number of terms, and divide by 2. So for example, the sum of all the numbers from 1 to 100, our first number is 1. Our last number is 100. It's an arithmetic sequence because the common difference is 1. So you add 101, divide it by 2, and multiply that by the number of terms, which would be 100. So that would be an easy one to come up with now. So let's look at an example of how we might see this in a homework problem. We want to evaluate the sum from n equals 1 to 20 of 7n plus 1. Now this is an arithmetic sequence. This is our formula for our nth term. So this is our nth term, and we want to find the sum from n equals 1 to 20. So we're going to use our formula here. So we need a couple of things. A sub 1. A sub 1 is just 7 times 1 plus 1. So a sub 1 is 8. A sub 20 is our last term. A sub 20 is 7 times 20 plus 1, which is 141. We're going from n equals 1 to 20, so n equals 20. We have 20 terms. So we're just going to plug into our formula. Our sum is 20 times 8 plus 141 divided by 2. If I plug that all into my calculator, I get 1,490. So that's one thing that's really nice about arithmetic sequences is I have this nice easy formula for my sum. I can find the sum of a lot of terms with this nice easy formula. Questions on that example? I'm just found my first term, found my last term, and I'm plugging into my formula for the sum. All right, let's look at a little more complicated example. We want to find the 15th partial sum of the sequence 2, 5, 8, 11, ... So to find my sum, I need to find several things. To use my formula, we need a sub 1, a sub 15, we need n. So we need those three things to plug into my formula. So how are we going to find a sub 15? What do we have to do to find a sub 15? Anyone? We could keep adding them and do it 15 times. But didn't we just come up with a formula for the nth term? We know that a sub n is a sub 1 plus n minus 1 times d. What's d here? 3. D equals 3. So we can find our 15th term, a sub 15, equals a sub 1, which is 2, plus 15 minus 1 times d, which is 3. So a sub 15 is 2 plus 14 times 3. And when I calculate that out, I get 44. So now I have my nth term, I have my 15th term. I can plug into my formula. S sub n equals n for our 15th partial sum. What's n going to be for our 15th partial sum? 15. 15 times a sub 1, which is 2, plus a sub 15, which is 44, divided by 2. And if I calculate that out, I get 345. Yeah, Cedric. Add it, yes. So the 15th partial sum is all the numbers for n equals 1 through 15. So the first 15 numbers of that sequence all added together. That's what the 15th partial sum is. So you're just taking 15 of those terms and adding them together. Okay? All right, questions on this? So what we need to remember for arithmetic sequences are two main things. And I'm going to do one application example. Our two main things. Our formula for our nth term. If we need to find our nth term, we can use this formula. We need to know the first term and our common difference. So that's going to be one key formula, is the nth term formula. And we did a couple of examples of ways that we work with that formula. And our second key formula is the sum of n terms, this formula for the sum. And that formula, for that formula we may also need to find our nth term. So that nth term formula becomes very important. So those two formulas are important formulas for arithmetic sequences. Those are the ones we need to remember, need to